Welcome again, section 1.5, and we're going to do applications of quadratic equations. So we're going to learn how to solve applications involving unknown numeric quantities, and then we're going to learn how to apply it to projectile motion and geometric applications. And again, we already talked about the steps for problem solving. I'm just going to go over them again because it's really important. So we want to read the problem several times until you have an understanding of what is being asked. If you can, create diagrams, charts, or tables, or draw a picture. If there's something you can draw a picture of, that will really help you. And then the next step, after we figure out what the problem says, we want to pick a variable that describes the unknown quantity to be found. So using X and Y, you can always use them, but they don't mean anything. Whereas if you're asked about a problem about motion, then you could say the rate is equal to something, right? You can say even R if you want to cut it short, but make variables, and you can write them as words, you can write them as letters, make them understandable to you so that when you find the answer, you know what you found. All of the quantities must be written in terms of that variable. So even if you can't at first, that means there's another equation somewhere that has those variables in it, and you want to solve one for the other so you can replace it and have one equation that has one variable in it. Okay, it can have a lot of terms, but it has one variable. And then it says write an equation using the given information and the variable. Okay, step 3, we're going to solve the equation. And then at the final step, make sure that your answers make sense, okay? If you find that one of the lengths of a rectangle is a negative number, I can assure you, you made a mistake because we don't have negative lengths. 2 things actually I want to say here. Make sure after you do all your solving, you read the question and make sure you're answering what the question says, and make sure that the answers make sense. Okay, so let's try one. The product of a number, x, times, so the product of a number and one more than 2 times the number, so that's 2x plus 1, equals 36. And I want to figure out what x is. Once I know what x is, I can even say this is y, just so that I can show you that there's 2 different numbers, okay? So this, you could say this is x times y equals 36, but I already know y equals 2x plus 1. So now how do we solve this? So first of all, step 1 says, read the problem several times until you'll have an understanding of what is being asked. So I look again and say the product, so I have a product here, x times 2x plus 1, that means product, and those are the 2 values that I'm multiplying, equals 36, okay? The next step is pick a variable. I already picked the variable. In this case, it doesn't really matter what the variable is because it doesn't mean anything except that a number, right? And then the next step is solve it. So I know there's a quadratic here because if I multiply these 2 together, I get 2x squared plus x equals 36. And anything that's squared is quadratic as long as it's the highest exponent. I subtract 36 from both sides, and I'll get 2x squared plus x minus 36 equals 0. Okay, and now I have a couple of possibilities. I can factor this, or I could use the quadratic formula. First I'll do it with the quadratic formula just so you can see how to do it. So I would say A equals 2, B equals 1, and C equals negative 36. Okay, so the quadratic formula is negative B plus or minus the square root of b squared minus 4ac over 2a. So I would get negative b, so that would be negative 1 plus or minus the square root of 1 squared minus 4 times 2 times negative 36 over 2 times 2, because a is 2. So that gives me negative 1 plus or minus the square root of 1 plus, I know it's plus because I have a negative here and I have a negative here. And then I have 36 times 8, so that becomes 288 divided by 4. And then I'm going to separate this into negative 1/4 plus or minus the square root of 289 divided by 4. Now, do we know what the square root of 289 is? Well, you can take out your calculator. So the square root of 289 is 17, which means I have negative 1/4 plus or minus 17 over 4. So now we're not done yet. So here, since we don't have a radical, we have just a number. Remember, this is equal to negative 1 plus 17 over 4, or negative 1 minus 17 over 4. So that's going to be minus 1 plus 17 is 16 over 4, which equals 4, or negative 1 minus 17 is negative 18 over 4. If I simplify that, I can divide the numerator and denominator by 2, and I get minus 9/2. So now I have the solution is either 4 or negative 9/2. So now let's go back and read the question. The product of a number and one more than twice the other number is 36. Find the two numbers. So if I go here and I find that x is equal to, let's say x equals 4, and we have another number we called y equals 2x plus 1, then this other number is going to be 9. And if we look, 4 times 9 is 36, and the second number is twice as big, plus 1 of the first number. So here's my two numbers. Okay, now let's see what happens when I do negative 9/2. I get x equals negative 9/2, and I get y equals 2 times negative 9/2 plus 1. Example 2. A toy rocket is launched at an initial velocity of 14.7 meters per second from a 49 meter tall platform. Okay, so basically, if I were to draw a picture, because remember the first thing I want to do is draw a picture if I can. So there's my platform, and that platform is 49 meters tall. And my rocket ship is on top. And we know it's launched at this initial velocity and the height of the object. So now when I launch it, it's going to go up, and then at some point it's going to come back down, right? So the height of the object at any time t, so we have the equation they're giving us is this is the height and t is time, and at any time t after launch is given by that equation. And it wants to know, when will the rocket hit the ground? Well, think about what is, because that's the question you have to answer. So we start with the height equals negative 4.9 t squared plus 14.7 t plus 49. And when will the rocket hit the ground? Well, I don't know the time that it's going to hit the ground, but I know that when it hits the ground, the height is 0, right? Because when it hits the ground, we're no longer at 49 meters, we're at 0. So I really just want to set h equal to 0 and solve this equation. And this equation with all the decimals is probably pretty difficult to solve unless you use the quadratic formula. We have 0 equals negative 4.9 t squared plus 14.7 t plus 49. And I could see if there's a greatest common factor, and I actually believe there is. So if you were to divide all of the numbers by, so just to tell you, let's do it over here. And if you don't notice this, just use the quadratic formula. So if you were to take 4.9 and divide it by 4.9, you get 1. If you take 14.7 and divide it by 4.9, you actually get 3. And if you would take 49 and divide it by 4.9, you get 10. So that is one way we could do it, where we could say this is equal to negative t squared plus 3t plus 10 equals 0. And now this is pretty easy to solve by factoring. So how I would solve this by factoring, first, I never like having a negative in as the leading term. So I can multiply both sides by -1, right? And if I do that, well, -1 times 0 is still 0. So I haven't changed my 0. And I get t squared minus 3t minus 10. And now I'll show you the easier factoring way, because now we have a equals 1, right? So a equals 1, b equals -3, and c equals -10. So I want to find two numbers that multiply together to give me a times c, and here a times c is -10. And if I add them together, it gives me b, and my b is -3. Okay, and then I can make my little table here on the side, or if you know what the values are, you don't have to make the table. So 10 is 1 and 10, 2 and 5, and that's really all there is, right? Now I have -10, so either 1 or 10 has to be negative. So because I know this is a -3, I'm going to make the bigger numbers negative, because when I add them, I get -9 and -3, and there's my two values. And now why I say this is the easier way to do it is because the last step, I don't have to factor by grouping now. I can just say the answer is going to be, for this one, we're using t. So t plus m times t plus n. Because a is 1, I don't have to go through the whole thing where I separate it and factor it out by grouping. I just use those values. So my answer here is t plus 2 times t minus 5 equals 0. So I have t plus 2 equals 0, or t minus 5 equals 0. I subtract 2 from both sides, so I get t equals -2, or I add 5 to both sides and I get t equals 5. So here's my solution to that equation, right? Now, remember, the last thing we do is to check to make sure it makes sense. So let's go back here, and I get a toy rocket is launched at an initial velocity of 14.7 meters per second from a 49-meter tall platform. The height h of the object at any time t after launch is given by the equation, and it says, when will the rocket hit the ground? Well, we have two possible answers here, but how can we talk about negative time? Could the rocket ship hit the ground 2 seconds ago? Obviously not. So we can just say this is called an extraneous solution. It doesn't, that solution doesn't make any sense for our problem because our problem is in time and time is always positive. Our answer is t equals 5 seconds.